So if you run Windows 8 or 10, if you run Windows 10, it's going to take up 1.7 gigabytes out of 2 gigs of RAM. So you only have 200 megabytes of RAM left to run all the applications all the apps that you need to run. Which pretty much means if you run your browser, you only get about 100 megs left to load actual pages.
It also depends on the browser you use.
Depends on, yeah, I think we were using Firefox, which is not the most frugal, but it's at the same time it's not the worst either. So I want to kind of show you guys, how much RAM I am using. So out of this machine has 16 gigs of RAM. So that's what this number is. It has got 16 gigs of RAM, and out of that, it appears that it is using 600 megabytes. So you got it right, 600 megabytes. And I have got the recorder going, the web browser going. It has got most of it used for caching purposes, which is optional. In other words, this will make the machine go faster, or seemingly go faster, but it's not 100% necessary. So out of all the stuff that is actually necessary, it's only using 600 megabytes. If I start up LibreOffice, let's see how much space that's going to use up. So we'll go back to this page here, and that's now up to 650 megabytes. So it's still less than 1 gig of RAM. If this desktop has only 2 gigs of RAM, I'm good for a while. I'll probably be good until like year 2020. Then I might be running a little bit tight, to the limit of the resources. Okay. Well, that kind of shows you how Linux, how frugal Linux is when it comes to using up RAM and processing resources and stuff like that. All right. First thing first, next Monday is final exam, so I just want to make sure that everybody remember, okay? Because this class starts at noontime. It's on a Monday and a Wednesday, so that's why our final exam day is the Monday the 16th. And the start time is 12:45. Okay? Sorry?
You said it's later?
It is later than the usual time. It has to do with, there'll be 2 more exams in the morning, and each exam is 2 hours, and then they leave 15 minutes between the exams. So that's why the final exam time is 12:45. It is not exactly at noon, which is actually good because most people show up, if they show up at noontime, then they will just be early. Okay, instead of the other way around, the exam time is earlier than the usual time. That is bad because most people come if they come at the usual meeting time, then they'll be late. Okay, so are there any questions regarding the final exam date and time? The duration is 2 hours, so it is 40 minutes more than our usual midterms. So you might want to make sure that you get enough rest, okay, before the exam. Okay. So with that out of the way, I did disclose all the final exams. So we have a whole bunch of final exams over here. No, wrong class. Okay, close that. There we go. So we do have some exams in topic 10. So we'll go ahead. That's the purpose of today, is to go over some of those. Okay, we may not have enough time to go over all of those. And this is also going to be an opportunity to look at how things can combine, passing by reference, arrays, and the records and stuff like that. Okay, so I'm going to show you some of these questions. This is a zip file. You can open it in Windows as well as any other operating system. So let me go ahead and unzip it. You can take a look at the content. This final exam. All right. So when you open up this file, it opens to a particular folder. And in the folder, we have several individual files. In that particular year, because we only had because the class was scheduled in a lab classroom, and that's why I use an electronic form of the exam, which means the students were able to use computers to answer the questions. All right, so let's go take a look at some of these questions. LibreOffice, we'll take a look at, I've named all of these exams after, cars, especially from initial D, just so that, I don't give away, what the algorithm is supposed to do. Okay. All right, so here's one of those questions. And this time we have passing by reference and array. Okay, so this is a combination of concepts that we have talked about, and until today we haven't seen this particular combination. Okay, so I'm not going to tell you the result for the actual trace right away. I want you guys to kind of think about it a little bit, and then I'll tell you guys, okay, how do we combine these concepts. So we'll just take an overall look at this particular algorithm. We have the invocation is here, and there are sheets already done. Okay, in other words, you do have a starting point with this particular one. We know that array B has 3 elements, and specifically they have value x, y, and z. Okay, and the question, well, sheet 3 is actually empty. There's no need for there's no need for sheet 3 to even exist. So in this particular question, we just want to track it down and find out what it's going to do. The XYZ is there because it depends on your student ID. Let me go back to the folder where I got this exam. So the cover letter, it's not even here. But the XYZ reflects different values depending on your student ID. So what I'll do is I will just put some random values into here, 23, 1, and 16. And then we'll trace this algorithm to find out what it is going to do with those values. So when you look at this algorithm, the only place that should be interesting to you is on line 2. Because on line 2, we are passing an array by reference, which is something that we haven't done before. We know what is passing by reference. We know what an array is, but we haven't seen passing by reference, how do we pass an array by reference. Now this topic is particularly interesting and useful because most of you are moving on to cisp300, where arrays can only be passed by reference. So there's no such thing as passing an array by value in C and C++. So this is actually particularly applicable in this class. So what I'll do is I'm just going to go ahead and do a trace. So we'll open up a new window to look at sheet number 2, which is the actual trace. And we have some initial values in the array already. I'm going to have to decrease the font size or the zoom of the algorithm itself, just so that we have more space to look at the trace on the other side. All right. Let's go ahead and get started. Okay, this is the precondition. We have one global variable, which is b. It is already initialized. So we want to start with line 10 and say, okay, this is a print statement. When we execute a quote-unquote print statement, it doesn't really do anything except on the comments column, you just say what it is printing. But I don't know what it's going to print because at this point, what it is going to print depends on the result of the invocation of evil. Okay, and since I haven't done it yet, I don't know what it's going to print. So the first time I get to line 10, I don't have anything to print, but I do want to invoke the subroutine evil. So when you look at the subroutine evil, it has return values. So what we need to do is to use a return info in this case, because we know that when we are done with this invocation, we have to go back to the same line that started the invocation, which is line 10. But there's something else on line 10 to finish up. So in the return info cell, we specify, okay, when we are done with this invocation, we have to get back onto line 10. But the question is, what else do we have to do on line 10? What do you think? Line 10 has an invocation. The invocation of evil has a return value. So the question is, when we get back onto line 10 after this invocation, what am I going to do? What else is left to do on line 10? Yep, go ahead.
You need to print whatever the result of the invocation is.
Yep, exactly. So we have to print whatever the return value of evil is. So that means, when we denote the return info, we specify we have to go back to line 10, and in parentheses, we use a question mark as a placeholder of the return value of this invocation of evo. So every invocation, every level of invocation has its own return info. All right, so now that we got this part done, let's take a look at the parameters. We only have two parameters according to line 2 and line 3 of the algorithm. We only got two parameters. Line 2 is the kind of difficult one. We'll deal with that later. Okay. And line 3 is the easy one because I, as a pass by value parameter, is just an integer. So when you look at line 10, what do I use to pass to parameter I? It specifies bar b bar minus 1. And the bar notation is going to tell you the number of elements in an array. And if you just look at the spreadsheet right now, how many elements do we have in B? 3 elements. 3 minus 1 is 2. So I, as a parameter, starts with a value of 2. Obviously, it does not need that much space, so we'll shrink it. Okay, so what is remaining here, which is the only really tricky part of this algorithm, is, okay, but how do we specify A? It is an array of integer, and yet it is passed by reference. So what you want to do is to think about the purpose of passing by reference. Okay? What is the purpose of passing by reference? Why do we pass by reference?
To modify something outside of a subroutine.
Most of the time we want to modify something that we are passing by reference. Okay, that's very true. Okay, so but regardless, we need to. So now that we understand why we are passing by reference, how is it done? So not looking at this particular example, just thinking about what we have done so far at this point. How do we pass something by reference? What is the mechanism? Yep.
You pass the address?
You pass the columns, right? You specify, okay, I'm not actually here, I'm just the alias of some other, either a single column or some other columns in this case. Is that okay? So in this case, since this is an array, what do we do? Columns in this case, because they're multiple. So because I use B to specify A and B has 3 columns, so in the notation here, we just say it is referring to column C to column E. Is that okay? So is this kind of what you expect? Yep.
I was going to ask, if on line 10, if there wasn't print, it was just invoke, would we use a return line instead?
You can use a return line in that case because then we just go back to post because there's nothing else on that line to finish.
But because it's print, you have to do the return info.
Because you have to get back onto the same line, and if the return line number is 10, then it becomes just kind of infinite because you will start from scratch again. You don't know where you left off if we just specify return line number. So that's the only difference. In other words, you can always use return info if you want to, because you can always specify return info to be post or whatever line is next to the invocation. But it does give you the flexibility of going back to the very same line and then specify what else do we have to do on that line when this invocation is over. Okay, that's a good question. All right, so now that we have passed the parameters, are there any questions about this part here? Passing by reference is always going to specify where do I find the original thing. If it's an array, what are the columns corresponding to that array? If it's a record, it will be the same thing. Which columns represent that record? In other words, it's always just going to be an alias. It's always going to be a call number. It's always going to be an address of, okay, how do I find the original item? Tell me which columns contain the original items. So in the test, what you need to do, if you're passing by reference, is you have to give columns, IDs, okay? Just like in this case, we have columns C, D, and E. You don't have to name every single column, just the ones that you have to refer to, okay? All right, so now that we have all the parameters specified, we can now get into the subroutine. There are no local variables in the subroutine. So we start execution on line 4. And line 4 starts with a conditional statement of I does not equal to 0. So I does not equal to 0 is true because I has a value of 2 at this point. So we now move on to line 5. On line 5, we want to specify, we want to execute a return statement. That's ultimately what I want to do. But I can't do that because I don't know what value I'm actually returning. So I can't really do much except to invoke evo again. And this time, we pass the parameters just a little bit differently, okay? So let me just kind of move this a little bit over so that we can see the entire line on line 5. And I'm going to do this trick here to split the screen. Okay, here we go. Okay, I'll split the screen like this. I'll just probably have to scroll over back and forth a little bit because the first thing we have to do is to specify, okay, what columns do I have to specify or allocate when we execute the invoke on line 5? Well, since it's invoking evo, we have to have 3 columns, basically the same labeling of the 3 columns. There we go. But this time the return info is not going to be 10 anymore because we have to get back onto line 5. On line 5, the only thing left to do is to the return, but we also have to finish up whatever is left on line 5 and specify that as part of the return info. Okay, so let me just kind of highlight this part here. So that's how we set up the return info. The second parameter, the first parameter is A, but I use A to specify A. So, and what we have learned before of not having a reference of another reference still applies. Okay, so nothing is really contradicting whatever we have learned so far up to this point. Okay, we do not pass the reference of a reference. So instead, what do? We have a parameter that is passed by reference into evo, and I'm now passing it by reference again to the next invocation. So what do? We just go ahead. Some of you know the answer. Okay, but once again, think about the purpose of passing by reference. The purpose of passing by reference is so that a subroutine has the capability of finding the original item. Okay? So when you look at how we set up the columns, the current parameter A, which is column G, it already tells us where to find the original array. Okay? It is referring to columns C to E in this case. So when you pass it along to the next invocation, the purpose of this particular parameter is still the same. Where do I find that array? So what should I put here in column J? Exactly. So you pass the reference along and say this is also known as columns C to E. Okay? So the mechanism is important because this is how I can test. This is what I need to see whether you understand the concept or not. So that's important. The mechanism itself is important. But what is even more important is the purpose of passing by reference. Okay? Because that will basically help you understand, okay, I have a combination of these concepts. How do I combine the concepts? You have to think about why do we have each one to begin with, so that way you can combine the mechanisms to accomplish that. So once again, in this case, we do not pass a reference to reference. In other words, this is not saying AKA column G. That's not what it says, okay? That is not correct. And what about I? I use my own I, which is column H, which currently has a value of 2, to specify the new I. 2 minus 1 is 1, so the new parameter has a value of 1. So column I, J, and K become the context of the new invocation. So at this point, I'm ready to go back to the beginning of the subroutine. This is a new invocation. On line 4, I ask the question, I does not equal to 0. It's still true because I has a value of 1, and we move on to line 5. You can probably already tell that we just have to copy and paste these 6 cells. For the most part, we have to modify one of them, but we can copy the rest. The only one that we have to modify is I, because I is the one that is decreasing every single time we go through one invocation. So now it is down to 0. but the parameter itself, we are just passing the reference along. So in this case, if I just, let me just do this part here. And scroll this so that we can display all three invocations. So when we look at all three invocations, you can see that A as a parameter, they remain to be referring to column C to column E because that's the purpose, okay? I need each invocation to be able to find which columns belong to the original array. Is that okay? Okay. All right. So now that we took a look at this one, we'll shrink the screen again, just so that we can finish up the last invocation. So now we move on to the last invocation. Every time you call a subroutine, every time you invoke a subroutine, you always start execution from the beginning. So once again, we go back to line 4. I does not equal to 0 is now false because I is actually 0. So now we go to line 7 to execute the else branch, and you can see that it's going to return the value of A bracket I. Okay, so now let's follow what A is. Okay, A is column M. Column M is referring to columns C to E. So here's a question. How do I know that column C to E is not a date? Because the date has year, month, and day of month, and it's going to use up 3 columns. How do I know this should be interpreted as an array and not as a record that has 3 integers? What gives you that confidence? What gives you that information? Line 2, very good. Line 2 is specifically saying that A is a parameter passed by reference, but it is also specifically saying this is an array of integers, and that's how we have to interpret column C to column E as an integer array. Okay. All right. So we want to refer to A bracket I has a value of 0, which means we want to refer to A bracket 0. Now A itself is a pass by reference parameter, which means it is simply an alias. It's saying that, oh, don't look at me, look at that thing that I'm pointing at. Okay. It's pointing at columns C, D, and E, and we want to look at columns C, D, and E as an array of integers, and we want to refer to the first element because the index is 0. So which column are we actually referring to in this case? Column C, the first one, okay, which has a value of 23. Okay, so 23 is the value that we are returning, which means we copy and paste the return info cell, and we change the question mark to 23, and we don't do any computation, okay? Even though we know that 3 times 23 is 69, we do not replace 3 times 23 is 69 at this point. This is not the time to do the actual computation. We only want to change the question mark to the value that we're returning. So when this is all done, we get out of the conditional statement, we get to line 9, which is the end of the subroutine, which has one simple thing to do and one sort of complicated thing to do. The simple thing to do is simply to copy and paste line 5, the return info cell. So this way we know which line we're going back to and what else we have to do on that line. And then the simple thing to do, well, the complicated thing to do is to copy and paste these 3 cells and just indicate that they're now deallocated. Okay, since they're deallocated, there's no need to look at them anymore. So by the time we get to line 5, those columns are gone. So by the time we get back to line 5, we have to look at column I, J, and K. And this time we want to compute, tell me what is A bracket I plus 3 times 23. That is what we're trying to figure out. So I in this case is column K, which is 1. And since we're using I inside a square bracket, we're referring to the second element of an array. The array is based on A, but A itself is not an array. A is just an alias of an array. A is saying, hey, don't look at me. Go look at column C to E and look at that as an array of integers. Okay, fine, we'll look at column C, D, and E. This is an array of 3 integers, and we want to refer to the second element, which is column D. It has a value of 1. So that means when we get to this line here, A bracket I, which is A bracket 1, is referring to column D, which also has a value of 1. So that part can be slightly confusing. And we are now computing 1 plus 3 times 23, which is 69. So the sum of this entire thing is 70. In other words, we are executing line 5 as if it is just saying return 70. If 70 is the value that we are returning, then we do the same thing as last time. We copy and paste the return info cell, change the question mark to 70, and we are done with the return statement. Okay, copy, paste, change the question mark to the value that we are returning, which is 70, and now we're done. You should not be bothered by the fact that the return info cell looks kind of like the statement that we're executing. It's okay, it's not a problem, okay? Because the only action you have to do when you execute a return statement is to change the question mark to the value that you're returning. If it looks the same as the statement that you're executing, so be it, okay? It's fine, that is not a problem. After line 5, we get out of the conditional statement, we get to line 10, line 9, and once again, line 9 has got two things to do. One is to copy and paste the return info cell to make a note of what do we do after this invocation is over. And then the second thing we do is to indicate that these 3 columns are no longer in use, they're now deallocated. And now we continue execution back on line 5. But this time when we get back onto line 5, columns I, J, and K are no longer in use, which means we have to go over to columns F, G, and H to establish the context in order to execute line 5. This line 5 says, oh, give me A bracket I again. It sounds like a simple thing, but I has changed because the I is now referring to column H, which has a value of 2. So we are putting a 2 inside the square brackets, which means we're looking at the third element of an array. The array is based on A. A is not an array by itself, but it is a reference to 1. It's referring to column C to column E. It's basically saying, okay, look at column C to column E as an array, and we are interested in the third element, which turns out to be column E. It has a value of 16. So A bracket I is resolving to the value of 16, and then 3 times 70 is 210. So we are now adding 16 to 210, which will give us 226 as a value, 226. So we are returning 226. So what do we do when we execute a return statement? We copy and paste the return info cell, change the question mark to the value that we're returning, which is in this case is 226, because it is 16 plus 210. That's all we have to do on line 5. We move on to line 9. And on line 9, we do the same thing. We copy and paste the return info cell itself so that we know what we have to do after this invocation. And then we have no use of these 3 columns anymore because this invocation is coming to an end. We mark these as strike through, and now we continue execution on line 10. Line 10 is simply saying, oh, print the number 226 on the screen. Okay, fine, we'll just print it. So we just say print 226, or if you just say 226, that's fine too, okay? Because that's all we're gonna print, and with the way we trace this program, there's no separate file for the output of a program, so that's how we use, that's what we do to denote that, okay, we're printing something here. And then after that, line 10 is now done. It's completely done. We are moving on, except there's nothing to move on to. We say post, and we are done with this particular trace. Are there any questions about this entire trace? Any particular role in the trace that you want to ask? And as I said, the only thing that is new in this case is passing an array by reference. But it doesn't change the original purpose or even the mechanism of passing by reference. It's just that now it is an alias of not a single column, but the entire set of columns representing the array. Now, I want to go back to an answer earlier, which is correct, okay? Why do we pass by reference? In most cases, we want to pass by reference because we want to change whatever thing that we are passing by reference. That is true. But in this case, did we change the array that is actually being passed by reference? In other words, if you look at column C, D, and E, did they change over the course of the execution of this algorithm? Are there any updates to column C, D, or E? What do you think? Nope, there are no changes, okay? So why do we still want to pass by reference in this case? Let me give you an analogy, okay? So let's go pick a really big, thick book, okay? Harry Potter, one of those books. There are a lot of words, right? Okay, so let's just say that as a student, as a group of students, okay, you guys have to take turns to count the number of occurrences of a particular spell. Okay, sounds like fun to you? Okay, so in that case, I don't want you to destroy or modify the book in the library. Okay, obviously, because the task simply involves, okay, I want you to count the number of times this particular spell is used in this book. So there's no need to destroy the content of the book. With passing by value, it means every single person has to make a copy of the entire book, do the counting, and then chuck the entire copy of the book into the recycle bin. Is that efficient? So basically, you know, as the instructor giving you the assignment, I'll give you a big, huge book about this thick, and then before you can do anything, you have to go to the copier and copy the entire book before you can start scanning through the entire book and look for the spell that you are responsible to find. Is that okay? And then I have to pass, and then you have to pass it along to another student and say, okay, I'm done with my part. Now it's your turn to find, you know, the number of occurrences of another spell. But when you are passing the copy of the original book to the next student cannot use your copy because it's passed by value. So the next student now has to make a photocopy of the copy of the original book, which is going to take up a lot of pages, right? And it goes along. So by the end of this whole thing, we'll have a copy of a copy of a copy of a copy of the original book. Is there a problem with this approach? Yep.
You're making copies over and over and over again.
Mm-hmm. Which is?
Recursion, maybe?
It is recursion, but you know, remember what I talked about a little bit earlier in this class? How about, you know, that your computer only has 2 gigs of RAM? Okay? What is the resource that we're running out of?
RAM.
Memory, exactly. RAM is memory, and that is the resource that is being chewed up when every single invocation has to make a copy of something that is huge. So instead of doing that, I can also change the approach and say, hey, this is the call number of the book that you can find in the library. How much space, how much paper do I need to write down a call number? Not a whole lot, okay? In fact, just because many of you do not know what a call number is, I'm going to show you how to find a call number. So give me the title of one of the Harry Potter books.
Harry Potter, the Sorcerer's Stone.
Okay, so Sorcerer Stone, Harry Potter. Okay. There we go. And then we just have to say call number. That should be able to locate it. All right, there we go. So the call number is right here, depending on, I guess, there are different revisions. So let's see. Oh no, I take it back. The Sorcerer's Stone has this particular call number. How much paper do I need to write that down, as opposed to making a photocopy of the entire book? Do you see the difference? So now, if I'm passing by reference, all I'm doing is this. Okay, since I now have paper in the classroom, I can actually do this. Okay. So I just write down, say PZ7.R79835 HAR 2010. Okay. And this is the only thing I have to give to the function, the procedure, or the subroutine. And now you know where to find a book. when I ask you to count the number of a particular cell, go find the book yourself and then do the counting. I'm not giving you a copy of the book. So when you need to pass on to the next student to find the number of occurrences of another cell, you still have to make a copy. The next student has to make a copy, but not of the book, only of the little slip of paper that has the call number. So by the end of the recursion, yes, we will still have multiple copies of something. There will be multiple copies of the call number, but not the book. Is that okay? So what I'm gaining is efficiency, because now I don't have to, one, spend the time to do the copying, and two, use the resources for all the extra books, for copies of the book. So that translates to execution time. The program becomes more efficient. It takes less time to execute. It also translates to memory efficiency, which means I don't need as much RAM to run this program anymore. Is that okay? And that is the reason why we pass arrays by reference. It's not just that sometimes we want to change the content of the array, which sometimes happens, and this time it did not happen. I did not change the content of the array. But it's also for the efficiency. We don't want to make copies unnecessarily, and passing by reference is a very efficient way for subroutines to pass basically, how to find something that can be relatively huge efficiently. So are there any questions about this particular program? Let me show you both the code and the trace and see if we have any questions before we move on to the next one. No questions? This is looking okay? Okay. So let's move on to the next question. I'm going to leave that one on the board, okay, on the projector, but we'll move on to the next one. So we'll pick MR2. I don't actually remember MR2 in initial D, but that's okay. Doesn't have to be there. Okay. So in this case, we have kind of the same deal. When you look at line 2, we have A being passed by reference again. And this time we have something that's kind of more interesting this time. When you look at line 11, we have an invocations that is inside a conditional statement, inside a condition of an unconditional statement. I think we have done it before, okay? We have been exposed to this before. But it doesn't really change the mechanism. It doesn't really change the mechanism of invoking and returning from a subroutine. It doesn't change the meaning of a return value. It doesn't even change how we do a conditional statement. Okay? All of that stuff is still pretty much the same thing. Okay. So let's go ahead and deal with this one and figure out what it is going to do with a particular array that's pre-initialized. So we look at sheet 2 again. This is the pre-initialized array. In this case, we have 4 elements in the array. So this one may take a little bit more space. Okay, so once again, we open a new window for the trace on sheet 2. And this way we can look at the algorithm on one side, and then we can look at the trace on the other side. Okay. And initially I can do it like this. Okay, we'll find a better way to do this, to display the content of both of these. Okay. All right. So this is a precondition. We don't have any other global variables other than B. So now we can start execution on line 11. Line 11 is the beginning of a conditional statement. So ultimately, what I want to do with line 11 is to decide, should I go to line 12 or should I go to line 14? That's the ultimate objective of a conditional statement, is to decide, should I go for the then branch or should I go for the else branch? But I cannot make that decision right now because the decision is going to be based on the invocation of MR2. Okay? So I have to first invoke MR2. And to invoke MR2, I have to specify the parameters. There are 3 that I need to specify. So let's go ahead and deal with that invocation and figure out what we have to specify here. I'm trying to find the best way to kind of do the screen layout so we can see everything that we need to. And at this point, let's see. That might work better. Yep.
I'm sorry, I'm a little confused. So, with if conditions, then you have a Boolean value.
Yep.
So what is it exactly asking on line 11?
On line 11, it's basically saying if the invocation gives you a return value of true, then go ahead and go to line 12. If the invocation gives you a value of false, then we want to go to line 14.
Okay.
Because the return value of a subroutine can be a number, but it can also be a Boolean. In other words, whatever expression is next to the return statement is whatever the value is being returned. So that can be a true false value, can be a number in this class, but when you move on to C and C++, it can also be a string, can be a character, can be anything that is the value, that is whatever is specified. Okay, so now let's move on here and specify how do we specify the return info for line 11. Okay, so this is the best way I can do it because I can show you both the parameter, I mean both the columns of the trace and also the code, and I can stretch it out a little bit more. Okay, so line 11 is, I cannot do the whole thing because I need to know the return value of the invocation of MR2 in order to make that decision. So when the invocation is done and I get back onto line 11, then only at that time I can do this, okay? Then I can say, depending on the return value of the invocation of MR2, go ahead and make a decision and see which line we should go to, whether line 12 or line 14. Are there any questions about how I set up the return info cell here? First of all, is this contradicting anything that we have done so far? Nope. Is it anything new? The combination itself may be new, but each individual concept is not new because it only involves one single concept. It's the concept of a subroutine that you're invoking has a return value. Replace the invocation with a question mark and then move on. That's all we're doing. Okay? All right. So next thing is to specify the parameters. A is the one that is passed by reference, but we already know how to do this, okay? If we want to pass the entire array by reference, we just say it is AKA and then which columns we're talking about. This time it's column C to column F. Okay, so parameter A, which is an array passed by reference, is now referring to column C to column F. Then we have the other two, I and K. Those two are pretty easy because they're passed by value. So that means I just gets a value of 0, K gets a value of 5. Now we have all the columns specified, and now we can proceed into the subroutine that we are calling. Okay, and I'm going to move this one down. Oh, I did something bad here. Okay, so the question is, if I undo, am I going to undo on a per sheet basis, or is it going to undo across sheets? I'm hoping you can do it on a per sheet basis. Oh, that doesn't look like that's the case, does it? Let's check. What was here originally? I think it's just define sub MR2. Yep, I think that's it. Okay. So I didn't lose much. Sorry?
Nothing important.
Nothing too important, correct. Okay, so I have to constantly check, what you guys are seeing because, I can actually see the bottom of the screen, but you guys cannot because of the way we put the projector. So let's go ahead and, I only have to see this part at this point, so we're still good. Okay, so now we're invoking the subroutine. We get onto the first line of the subroutine that we're invoking, which is line 5. Line 5 is checking is I less than bar A bar. Okay. So when we check whether I is less than the number of elements of A, then we have to say, okay, let's check what A is. Okay, A according to column H is referring to column C to F. And based on line 2, we know that those columns should be interpreted as an array of integers. So when you look at column C to column F, which are 4 columns, and see it as an array of integers where one integer occupies one column, then you can say, oh, it's an array of 4 elements. In other words, bar A bar is 4. Is that okay? Does everybody understand how I know bar A bar is 4? Okay.
Can you explain that again, please?
Okay, so we look at bar A bar on line 5. We want to figure out what is bar A bar. What is the meaning of the bar bar notation?
Oh.
The number of elements of whatever is in between, right? Okay, so whatever is in between is A, which is a parameter that is passed by reference. So when we look up the name A, it will give us column H and say, okay, column H has a label of A. This is what we are talking about. This is A. Oh, but A is not an array itself. It is just the alias of one array. In other words, A is just saying, don't look at me, look at column C to column F. Fine. We look at column C to column F, we see 4 columns. But how do you know these 4 columns is an array of 4 elements? Well, then you look at, okay, it's an array of integers. And with an array of integers, one integer takes up 1 column. So when you have 4 columns, you have an array of 4 elements. So next time I'll give you an example where you can look at 4 columns, but the cardinality or the number of elements in an array is not 4, okay? Because you can have an array of records. Okay, so we'll combine those concepts as well later on. So now we understand bar A bar is 4, I is 0, 0 is less than 4 is true. So we go to line 6. Oops. Bar I is less than bar A bar is true. We move on to line 6. And line 6 is kind of a long line too, but that's okay. We just have to say, we cannot really quite do the return because I don't know what to return until the invoke is done. So now we need to use return info to go back to line 6 and specify when we get back, then we'll evaluate the rest of this line. Okay? And replace the invocation itself with a question mark. Then we have to specify the other columns for the parameters. A is a parameter that is passed by reference to me, and I have to pass it by reference to somebody else. That's easy. It's just, I'm just passing that reference along because the objective is for the next invocation of this same subroutine to have the ability to find the original array. So you just have to pass the reference along. The other two parameters, one has to change, okay, which is I. I was 0, passed to me, so now it is 1. Pass it to the next invocation because it's I plus 1 that is being passed to the next invocation. And then K is not changed because according to line 6, we just pass K along as it is. So K is still the same value as me, so it is still 5. Are there any questions about how these 4 columns are set up for the new invocation? Okay. And I don't want to look at this whole thing and having to scroll around all day long. So I'm going to use this technique again just so that we can focus on the current invocation. So once all the columns are set up, we continue execution on the first line of the subroutine, which is on line 5. Once again, it asks bar A bar, is I less than bar A bar? It is still true because I is less than 4. We move on to line 6. And we just copy and paste these 8 cells, and change, the only thing I need to change is I, because everything else stays the same. So I has to increase by 1. So I just need to scroll over this. I is going from 1 to 2. Then we continue execution on line 5. And then we do basically the same thing. I is now 2. 2 is less than 4 is true. Go to line 6. We look at this and go like, one more time. Okay. Copy and paste. And change the parameter I to 3 because that's the only thing that gets changed. when you look at line 6, you can see that A is being passed to A, K is being passed to K. The only one that is changed is I, because I use I plus 1 to specify the new I. So now we just resize the column a little bit, go back to line 5, because that's the beginning of the entire subroutine. I is less than bar A bar is true, because I is 3, 3 is less than 4. We go to line 6 one more time. Once again, we copy and paste, because the columns are set up pretty much the same way, except for I is now 4. So in this very last invocation, when we go to line 5, I, which now has a value of 4, is less than bar A bar, which is also 4, is now false. So we cannot go to line 6 anymore, and instead this time we have to go to line 8 to return false. So now we go from line 5 to line 8, and we are now returning false. How do we return false? Well, whatever you're returning, you just use that to replace the question mark. If it's a number, use the number to replace the question mark. If it's true, you use true to replace the question mark. If it's false, you use false to replace the question mark. So in this case, it's pretty clear cut, it is false, so we just use false to replace the question mark. Okay, so here, this is the question mark right here. Control C, Control V, copy and paste, change the question mark to false. There we go. And we're done with the return statement on line 8. After that, we exit the conditional statement. We get to line 10. On line 10, we got 2 things to do. First, to remember where we're supposed to go back to. Then we have no use of these 4 columns anymore. Just go ahead and deallocate these 4. And strike through. So now we can move on to line 6. But when we are on line 6, columns W, X, Y, Z are gone. So now we have to refer back to column S, T, U, and V, which is really kind of hard to see because they're all the way up there. Okay, but before we go there, we have to look at the line 6 as it is right now. So it's saying, okay, let's go ahead and evaluate whatever is to the right-hand side of the return. Okay, but that looks like a condition to me. Yes, it is a condition, which is really just an expression. It can be evaluated, it'll give you a value. So let's go ahead and evaluate it. A bracket I, okay, what is I at this point? If you go back to I, it has a value of 3. So A bracket I is referring to A bracket 3. But what is A? A is referring to column C to column F, and it's saying, okay, look at those 4 columns as an array of integers. So A bracket 3 is referring to the 4th element of the array that is currently occupying column C to column F. And if we go all the way back, you can see, oh, A bracket 3 or B bracket 3 has a value of 1. 1 equals to 5 is false. And then the other side of the OR is false. So now we have false or false, which is false. Okay, so that means we're just returning a value of false. We copy and paste the return info cell, change the question mark to the value that we are returning, which is false, just like that. And now we are done with line 6. After line 6, we continue on to line 10, which is basically kind of doing the same thing as last time. Copy and paste the return info cell, and then just indicate those 4 columns are now deallocated. Let's see, go here, right click, and strike through. So now we're back onto line 6. But this time, columns S, T, U, V are gone. So we have to reestablish our context using columns O, P, Q, R. And in this case, I has a value of 2. K is still 5. K has never changed. So now we have to look up here and say, okay, what is A bracket 2? It has a value of 5. Okay. So A bracket I has a value of 5. K is 5 as well. So we have true on the left-hand side of the OR. Using short-circuited evaluation, we don't even bother to check the OR. Okay, so we just say, oh, we're done. I made a mistake earlier. Let's see if you guys spot the mistake. I have one invocation too many. because I forgot to apply short-circuited evaluation. Did anyone kind of have that idea that, wait, this doesn't look right? No? Yep.
You have the same thing on line 21 and line 23.
Okay.
Got it?
Let's go ahead and expand this one so we can see a little bit better of the history of how we got here. So with an OR, what you do is always evaluate from left to right. Right? Remember that? With a plus, you don't always do that. With a subtraction, you don't always do that. But with logical operators, with an AND and an OR, you are required to evaluate from left to right. Is that okay? So that means by the time we evaluate this one, we already know the result even though we have not invoked. In other words, this invocation should not even be there to begin with. Because by the time we get to this line 6 and we evaluate, oh, what is the expression that we're returning? We're trying to evaluate this expression. But with this expression, the left-hand side of the OR is already true. Which means I don't even need to invoke the subroutine again because I already know the entire expression is true. That's where my mistake was. Is that okay or not? Sort of? No? Okay, let's take a look at the original code. So I'm going to undo this part here. Okay, so we'll go ahead and undo all of this and clean up all of that too. And all of that. In other words, this trace is actually a lot smaller, a lot cleaner than what we originally thought it would be. And in fact, on this line, none of this needs to be evaluated. Okay, so we'll go ahead and change the screen again, like this. We're on line 6, so I'm basically going back in time to line 6 and the current context. We're on line 6, and we want to evaluate return a bracket I equals to k or blah, 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 okay? This is where we are at this point, and the columns, oops, KLMN is our current context, okay? So this is where we are back to, this in order to undo my mistake. Okay, so we're back on the line 6. This is the first time we get to line 6 in this particular invocation of the subroutine. And we have to evaluate, okay, tell me the ordering of the stuff that we have to do on line 6. This is the first time I get to line 6. What is the first thing that we need to do? Okay, let's look at it from the other perspective. What is the last thing we have to do in this case on line 6? What is the very last operation of line 6? Is it the OR or is it the return? Which one is the last one? The return, very good. Okay, so that means, okay, I'm going to use the document viewer. Okay. All right, so on line 6, I'm going to repeat the whole statement here, just so that we can refer to it. So line 6, I'm just copying right now, just don't mind me, because I'm just doing that. Copy and paste using pencil. It's going to take a little bit longer. Okay, all right, let's switch back. Okay, this is the line that we are talking about. This is line 6. Can someone tell me what is the ordering of things that I have to do? What should I do first? Yep.
You have to check a bracket I equals k. You
Yep.
have to check if that's true.
Yep, because we are evaluating a Boolean operation, a logical operator, which is the OR, and we also use short-circuited evaluation. I forgot, okay? I myself forgot that we have to use short-circuited evaluation and always evaluate from left to right. So in order to do this, we have to first evaluate what is A bracket I equals to K. So I look at I is a parameter, it is 2. I look at A, it refers to the columns, yep.
I doesn't become 2 until the invoke.
Nope, but we are already in the invoke. So when you look at the trace, we are currently already there. Oh, you're right, I deleted too much. But the mistake is still true, okay? So I have to look at this, I is 1 at this point, because according to the trace here, I has a value of 1. I still have to do with that, I still have to evaluate that first, okay? So I is 1, so we're looking at A bracket 1 equals to K, K has a value of 5. But A bracket 1 is B bracket 1, and B bracket 1 is also, has a value of, I cannot remember, 6. Okay. So we're looking at 6 equals to 5 as the left-hand side of the OR, and, oops, you cannot see what I'm writing, there you go. 6 equals 5 is false. So this entire thing evaluates to false. If I know the left-hand side of a disjunction or is false, do I have to evaluate the right-hand side? Yes. Because it's an OR, with an OR, if the left-hand side is false, we have to evaluate the right-hand side. If it's a conjunction, then it's the opposite, okay? So in this case, now we have to evaluate the other side. So in the trace, technically speaking, in the trace, we should, where is it? There you go. So in the trace, when we execute line 6, the return info cell is a little bit different from what I showed you guys earlier. It is going to be, we have to go back to line 5, but the first part of the OR is now already evaluated. It has a value of false already. So it really should look like this. And the same thing applies to the one before. This one here should also be changed, because by this time we would have already evaluated this part and know this is false. Yep.
You said line 5, I think it's supposed to be line 6.
Yeah, this one's supposed to be line 5. There we go.
No, it's supposed to be line 6. That's not the right subroutine.
No, this is the correct one, because we have to return to line 5 to finish up line 5.
That's not the one we're tracing right now.
Correct. That one is also incorrect. And this is supposed to be line 4. That's
No.
line 5.
You're missing
So
it.
that's the last.
Oh, okay, I see.
Yeah.
Gotcha. Okay. We have the wrong algorithm. It's better to close it. So this is the right one. Okay, we are tracing this particular one. So the line numbers of the trace was actually correct. It's just that I got the code itself as that. There we go. So this is line 6. Sorry about that. And the earlier one, this one is correct. And this one needs to be fixed too. There we go. All right, so this is line 6. We have to set up all the extra parameters. So we have A, I, and K. K is still 5, I is 2 in this case, and K is still AKA columns C to F. There we go. So now that we have, this is the last invocation, because by the time we get to line 5, this time, I is less than bar A bar. It is still true. However, when we get to line 6, this time when we evaluate line 6, the first thing we want to do is to figure out whether A bracket I equals to K or not, because we are forced to evaluate from left to right with a OR statement, or with an OR expression. So at this time, I has a value of 2, and A bracket I is basically referring to B bracket 2, which is 5. 5 equals to 5 is true, so that means at this time, we already know the whole thing is going to be true. So on this line 6, we already know that we're going to return a value of true, so we copy and paste this whole thing and change this to a true.
Change the false
We are not changing the false to a true yet. Because remember, when you execute a return statement, you're only changing the question mark, and you're not evaluating the return info cell itself. But the reason why we have a true here is because A bracket I is A bracket 2. A bracket 2 has a value of 5. 5 equals 5 is true.
I guess I'm hung up on how you can put the true in the parentheses when you got the true from the A bracket I.
Okay. Okay, before this point, is everything okay?
Yeah.
Okay. So we are, this is the first time we get to line 6 of this particular invocation. Is that okay? And as a result, the first thing we need to do is to say, okay, what value am I supposed to return? That's what it wants to figure out. But since the expression that is giving you the value to return is a disjunction, now you have to use short-circuited evaluation, which is forcing you to evaluate from left to right. So when you look at the expression on line 6 and you say we have to evaluate from left to right, then you're not gonna worry about the invoke just yet, because you want to evaluate from left to right. So the first thing you want to do is to say, what is A bracket I? And then you look at your current I, it has a value of 2. Is that okay? So A bracket I is A bracket 2. Then you look at A and say, what is exactly A? A is an array of integers that is living in columns C to F. So you go back to column C to F and you say, okay, give me the third element of this array. It has a value of 5. 5 equals 5 is true. And also based on short-circuited evaluation, when you have true on the left-hand side of a disjunction, you do not evaluate the right-hand side. So you already know at this point that the whole expression on line 6 is just true. We do okay so far? So in other words, we are now executing return true. What do you do when you execute a return statement?
What's the question mark with what you're returning?
Exactly. So that's why we copy and paste the return info cell and just change the question mark itself to true. But this is not the time to evaluate false or true is actually true. We are not back to that line 6, because that belongs to an earlier invocation that we are not in at this point. Is that okay or not?
We can move on.
Okay, but this is really kind of important, because even though it seems to us it's obvious that false or true is true, we do not simplify at this point. This is not the right time to simplify it. Okay? Yep. Okay.
I have a question about when exactly the question mark becomes false.
Okay.
You said that you can only evaluate the question marks when you update the line
When
inside
you
of a red info. But you changed the very you navigate to where you first added the
okay, so you want me to go back?
I think it's line 7.
Row 7?
Line 8.
Okay,
You mean this one?
yes.
Yes. So this one, so the question is, why do we have this line as return false already and not A bracket I equals to K? Because it's already evaluated.
So it's just like another expression, basically.
Well, we have to reflect what we know at that point, so that we know that when we come back, what else do we have to do? But we have already evaluated the left-hand side at this time, so we have to write down, oh, we have already evaluated the left-hand side, and the result of the evaluation is a false.
It's just more helpful than having A of I equals to K.
You can do that too, but if you specify A bracket I equals to K, then it is not obvious that we are using short-circuited evaluation. This way, it is really obvious that we are actually making use of short-circuited evaluation. Is that okay? I mean, does it kind of explain that? Okay. All right, so we can now continue onto this row here. Okay, so when we execute line 6, we change the question mark from question mark to false to true. Then we're done with line 6, and once line 6 is done, we move on to line 10. And on line 10, we just copy and paste the return info cell to remind us what else we have to do, and then we deallocate these 4 columns. So we don't quite go use as many rows as we originally did. And now we're back on the line 6. Now we evaluate what is false or true, and then we say, oh, false or true is just true, and now we are returning a value of true. When you execute return true, then you go to here, you just copy and paste it, change the question mark to the value that you're returning. It is true, okay, uppercase. There we go, and you're done. Now, is there a problem? This is the statement that you're executing. This is the result of executing that statement. It should not bother you, okay? Because that's simply, it just so happens that they look the same. They can look the same if they want, if they need to. So now we move on to line 10, same thing. We look up, we copy and paste the return info cell to remind us where we're supposed to go. And then we deallocate these 4 columns. There we go, copy and paste. Get rid of these 4 columns. And now we go back to line 6. We're now trying to evaluate what is false or true, which is true. So we return true again. Every time you execute a return statement, you look for the return info cell. This time it's a little bit up here, and we replace the question mark to the value that we're returning, which in this case is true. But we don't do a single thing. This is not the right time to say, oh, this is a conditional statement. We have to go to either the then branch or the else branch. This is not the time to do it. It's just the time to change the question mark to a particular value. Then we go to line 10. We make a note of where we are supposed to go. Then we deallocate the 4 columns. So now these 4 columns get deallocated right here. And indicate that. Now we continue execution on line 11. Line 11 is the beginning of a conditional statement, and now that we know that the condition itself is true, then you just say, oh, now we can finish up the conditional statement because true is true. So we go to the then branch, which is on line 12, and then we print mid-engine. And after line 12, we have nothing else to do because we'll be exiting the conditional statement, and we go straight to post. Okay, let's zoom out and see whether you guys have any questions, because I'm pretty sure you guys should have some at this point. So this is the overall trace, and we can reduce the width of some of the columns because they don't need as much space as before. All right, and we'll zoom out just a little bit so we can see the entire thing. Yeah, go ahead.
Okay, so line 13.
On row 15?
No, line, yeah, row.
This row. Yep.
No, yeah, 13.
13. Okay.
Okay, so we're returning false or true, which is true, but both the false and true came from evaluating A bracket I equals to K.
But in different invocations.
Okay.
Okay, so let me just emphasize the key concepts involved on this particular row, because there are like a whole bunch of concepts involved. The first concept involved is short-circuited evaluation. So in this case, when we get to line 6, okay, this is where the document camera can be helpful. So when we get to line 6 this time, this is when I equals to 2. So we evaluate A bracket 2 equals to K, and that turns out to be true. Is that okay? So in this case, this whole sequence is off because I is actually 2 in this case. So A bracket 2 evaluates to 5, and the 5 equals to 5 is true. okay? But because it's short-circuit evaluation, we don't bother to evaluate the right-hand side. And we can conclude right away and say, you know what, this entire expression here, because the left-hand side of the OR is a true, this entire thing is just true. So we execute return true as the action that we're performing, okay? But when you execute return true in the trace, what we do is we just locate the return info cell of the current invocation, copy and paste it, and then change the question mark to the value that we're returning, which is just true. But that's the extent of what you need to do when you execute a return statement, is just to change the question mark to the value that you're returning. So the concept that is involved here, first of all, is short-circuited evaluation. We evaluate the OR from left to right. And we only have to evaluate as much as needed to come to a particular value and a conclusion. That's concept number one. Concept number two is once we know the expression on the right-hand side of the return is returning true, then we execute the return statement. So the concept number two is what do we do when we execute a return statement, knowing what value we're returning. We look up the return info cell of the current invocation, we copy and paste, and then we change the question mark to the value that we're returning. But we do not do anything else with that return info cell. That's concept number two. So those are the two main concepts in this case. Now there's array indexing, passive by reference, and all that stuff too. But the main point of confusion is separating what we're executing and also what we're supposed to do when we execute the return statement. Is that better?
Yeah.
Okay. Yep.
Number line 8.
On row 8?
Row 8.
Uh-huh.
And, how do you under column K
Uh-huh.
it says return false or parentheses question mark?
Yes.
Where did you get the false?
The false is coming from the evaluation of a bracket I equals to k. Because we have to evaluate from left to right. Okay, let me put this in another way. How do I know that we have to evaluate from left to right? Which forces us to evaluate to know that the left-hand side of the OR is true. But why do I have to evaluate from left to right?
That's the way like the computer would look at it.
Right, because it has to do with OR being a, we use those terms already today. So OR is a blah, blah, blah operator.
Logical.
Logical operator, exactly. So OR is a logical operator. When we evaluate, when we evaluate an expression with a logical operator, what has to apply? That does not apply to any other expressions, but only to logical operators.
Left to right.
Left to right, but more importantly, it's called short-circuited evaluation. Okay? So that means, when we execute this line 6 at this point, we have no choice but to evaluate from left to right. But the left-hand side of the OR is a bracket I equals to k, which at this point will give you a value of false. So by the time we do the invocation, the left-hand side of the disjunction or the OR is already known to be false. And we have to record it as the current state of that line 6, so that when we come back, we do not have to evaluate the left-hand side again, because it's already done. It already tells us it's false. Is that okay? Is that answering your question? Okay, yep.
Should we put the conditional evaluation in the comments or?
You can if you want to, but since it really doesn't change the flow of the program, that's why I don't do it that way. But if you want to add more items to the comments column, that's fine. Yep.
On line 20 in the trace, why does the print statement go in comments?
Why is the print statement
In comments.
in comments? Because when we print, there's nowhere else to specify what you're printing. So I'm just using comments to indicate this is what we're printing. Because there's no separate sheet to specify, oh, this is the actual output of the program. So when we print something, I just hijack the comment columns to indicate on this line, we now print this to the screen. Yep.
So, on line 11, it says like a return F or question mark.
Yep.
So like when you get to line 13, it says return F or return false or true. Like is there like a reason you have to find the question mark if you already know it's gonna be false?
Say that one more time.
Oh, like is there a reason you have to find the question mark on the right even though you already know it's gonna be false anyways?
No, the question mark is unknown.
Okay.
The question mark indicates that this is to be determined by the invocation of this subroutine.
Okay.
So
yeah, we have to find it no matter what, even if we know what's gonna end up at.
At this point on row 11 of the trace, we already know that the left-hand side of the OR is a false. But in a disjunction, in an OR, if you know one side is false, it is not conclusive because the other side now
Okay, so you have to find it anyway.
So you have to evaluate the right-hand side because a false with an OR is simply saying, okay, we know that we don't know yet, okay? Because when you have false or whatever, it is whatever.
Okay.
And that's why, at this point, I have no choice but to actually invoke the subroutine because if I just know the left-hand side of the OR is false, I cannot conclude the actual value of the OR. Now I have to evaluate the right-hand side as well, but since the right-hand side itself is an invocation, and that's why I'm doing the invocation, and this is just a convention of when you invoke a subroutine that has a return value, the return value itself is a placeholder, and that's what the question mark is.
Alright.
Okay, yep.
On line number 19, you know that if it's true, then you go to line 12 and print mid-engine.
Right.
Did it specify that true is you should pick mid-engine? Because I just remember on the trace it just said if invoke then, but it would just be if true then.
Okay, I can understand the question. Let me flip to that logic first. I'm just trying to find out which one. Okay, it's another MR2. There we go. There we go.
Because this is if and then the
Yeah.
invoke then. So how do we know that if it's true?
Because that's the definition of a conditional statement. Whatever condition you put inside the conditional statement, which is the stuff that is between the if and the then, is the condition that you use to determine which way to go.
Okay.
So if that whole thing evaluates to true, you go for the then branch.
Okay.
If that whole thing evaluates to false, you go for the else branch.
I just wanted to.
Okay. So we have a few concepts kind of stacked on top of each other, but the ordering of the evaluation is important. Okay, so when you look at this whole thing, it's like, oh, this is a one big mess of all the concepts that we have learned. But when you execute the code, you're still only applying basically one concept in each step. So the question is, how do you sequence the application of these concepts? Is that okay or not? We still have Wednesday, so I want you guys to at least go over this one. I can see a lot of people kind of looking at this one and go like, wow, this is a lot of stuff. So you might want to go over this one, before Wednesday. And then the other exam questions are open as well, so we can do all of those. Given, depending on how much time we have on Wednesday, we can go over all of those exam questions. And let's make sure the recorder is actually running. Yes, it is. Well, sometimes, and the recorder and the mic is going as well.